Example 3, just like last time, we're going to take this equation and we're going to move that 2 to the other side. The other thing we're going to notice in this one is you see that you have a 3 inside the square root. That first 3 is going to be a horizontal compression. And the second 3 is going to be a horizontal translation. And this is where that special note comes into play. Whenever you have a horizontal stretch, compression, or reflection with a horizontal translation, we need to write this in factored form. So I'm going to factor out the 3 and write x plus 1. That's the factored form. And because there's a horizontal compression with a horizontal translation, this one is not getting moved 3 to the left. It's going to get moved 1 to the left. And then I'll move that 2 over to the other side. So everything is matched up. I can now go from left to right and label things. This negative is outside the function, so it's going to be vertical, and negatives are reflections. So we have a vertical reflection. We have a horizontal compression. That 3 is inside the function. We have a horizontal translation. And finally, that 2 is outside the function. We have a vertical translation. So what we're going to do is we're going to set things up for our translations. We have a regular square root graph. We're going to take 0, 0. That's a key point. I'm going to set things up with an arrow for my stretches and compressions, an arrow for my translations. And above them, vertical reflection. That means I'm going to multiply my y's by a -1. The horizontal compression tells me I'm going to multiply my x values by 1/3. Horizontal translation, that's going to go 1 to the left. And vertical translation, that's going to go 2 up. So now everything has been labeled. And the reason I labeled that first is because when I pick my second point to see where it's going to go, I could choose 1, 1, because that's on my square root graph. I could choose 4, 2. Can you see with both of those points that if you did that, when you multiply your x values by 1/3, you will get fractions? Not that that's bad or the end of the world. It just means that you're going to have to do harder mental math when you have to move left 1 and up 2. Can you see that if I chose the point 9, 3 as my second point, I avoid fractions? And don't worry. I know you're probably thinking, oh, Mr. JR, I really want to practice fractions as much as I can to get that math skill as best as I can. Maybe I'll choose to do fractions every chance I get. Don't worry. We get to do so much with fractions this year. You will become experts in fractions by the end of the year. If you want to start practicing early, you can, but it does make life easier if you don't have to use fractions as much as possible. But don't worry if I'm like skimping you out of an education. We'll do lots of fractions this year. But for right now, this is a good choice. So we're going to look at what happens to that point as well. So y by a negative, x by a third. Well, this is easy. It's still going to be 0, 0. Then 1 to the left and 2 up. Second point, x by a third. Oh, that's nice. It's not a fraction. And then y by a negative. Finally, 1 left, 2 up. We get those 2 points. Now, this graph isn't overly complicated, so we will graph on the same one. -1, 2. Careful, this grid is going by 2s, so -1, 2 would be right there. And 2, -1. This is our starting point, so that's corresponding with this one. That's going to tell you that you need to start from that point when graphing this. And the last thing we need to make sure is that we have the shape correct, the curve correct. Now, what can help you with that curve is think about your original graph. If you went from left to right, what does a vertical reflection do? That's going to flip that graph down like this, right? So we have this curve already in that shape. Then it gets stretched and compressed, but that shape should tell you that your final shape is going to look like that. Questions for practice on this one are 8 and 10. This question did say, what are the domain and range of our final graph? So we'll do that as well. We haven't used interval notation for a while, so our domain, our smallest x value is -1. We'd put that with a square bracket and go to infinity. For our range, it goes down forever, so there is no smallest y value. So we start at -infinity and we go up until we get to 2. 2 is included, so we put a square bracket on that.